Thank you. So to clear the elephant in the room real quick about Dow Jones, you might know our industrial average, but fun fact, we don't actually own that. So we sold that back in 2010 to CME Group. And nowadays, that is controlled by the CME Group, S&P, and News Corp, which is also our parent company. Nowadays, we're more of a media company. We own a bunch of companies that you might know, such as Wall Street Journal, Barron's, Wall Street Journal Pro, MarketWatch, FN London, Factiva, amongst many other companies. At Dow Jones, I'm currently working with 3 other developers as the Graph Stewardship Group. Here's a picture of my team. We're saying hi from New York, New Jersey, Boston, Mississippi, and Mexico, quite dispersed. And we might be a small group, but we do maintain a pretty large supergraph. Currently, we have 17 subgraphs, 105 queries and mutations, and 422 types with 3,000 fields. This results in approximately 11 million requests per day that get past our CDN. We're currently working on onboarding teams to transfer ownership over for some of these subgraphs, but in the meantime, these numbers continue to grow every day as new business requirements come in, new bugs are found, and worst of all, non-nullable fields needing to be deprecated and made nullable. As you can imagine, working on this many subgraphs gets complicated. Luckily, we have the Rover CLI. This allows us to connect our local changes to variants currently deployed in Apollo Studio via the Rover dev command. While this is perfect for some use cases, we found that Rover dev can get quite messy at scale. Each time we wanted to test local changes for a branch, we had to update the routing URL and subgraph URL to point locally in the Supergraph YAML. We also use introspection headers that expire every 24 hours for security, so we'd have to manually update those on every subgraph in the YAML. Lastly, with our infrastructure, we had to open up separate terminals to run each of the local subgraphs. While not too bad for one subgraph, when adding a new federated directive like the requires one, we might need to work on multiple subgraphs at once. Up here, you can see a sample YAML. This is only for 4 subgraphs, so while it might not look too cluttered, try maintaining this thing with 17. So, at that point, I had a thought that lots of us probably have had at one point or another. Let's do a little raise your hand exercise. Raise your hand if you've ever had that thought of, I can just fix it myself. And then you had too much time it took too much time and effort. So, I was like some of you, but I had a free weekend and nothing better to do with my time. So, that's when I made Rover Runner. Rover Runner is a Visual Studio Code extension that lets you configure different combinations of local and deployed subgraphs. When you hit the play button, it'll run the local subgraphs, in our case via NPM, and then dynamically generate a Supergraph YAML with all the appropriate URLs and up-to-date auth keys. Lastly, it uses the Rover CLI to run the Rover dev command to start up your router with that Supergraph YAML. Watch, I'll show you in this video demo. So here, we have a supergraph composed of 2 sample subgraphs. I'm going to click on Rover Runner on the left, and then I'll click Generate Template to create an example configuration. This will create a Rover Runner folder with a Supergraph JSON file. This is not to be confused with the Supergraph YAML file, which it'll generate later. Here, you'll see sample configurations. These show you how to properly configure the file. Path is the local route to the subgraph, local URL is the local URL to call it, and dev URL is optional, but it overrides the Apollo variant URL if provided. For our use case, we're just going to set the local paths for subgraphs 1 and 2 to their corresponding folders, and we'll fix the ports for both the local URLs. While I'm doing this, at the bottom, you've probably noticed that Supergraphs section. This lets us configure multiple collections of subgraphs that you might want to run together. For example, at Dow Jones, I have one configured for just the user-related subgraphs, since I don't want to necessarily have all 17 in my sandbox. Once the Supergraph JSON is fully configured, we can go back to the rocket on the left and hit the refresh button. This will update the menu to show the new configuration we've created in our Supergraph JSON file. Before we run our Supergraph, though, we'll need to set our settings. So let's click on the settings gear in the upper right. Here, you'll see all the settings for Rover Runner. First, you'll see this auth header. This is applied in the Supergraph YAML file to allow Rover to introspect subgraphs for their schemas. Next, you also have the option to set different federation versions and router versions. If you'd like, you can also rename the Supergraph JSON file to avoid any confusion with the Supergraph YAML. Below that, we have a Use Redis checkbox. Dow Jones currently uses Redis for caching at the subgraph level, as well as the data source level. So I added this little checkbox that uses Redis CLI to automatically start up a Redis server for the local subgraphs. Saving the best for last, we have the graph ref and Apollo key populated with my sample values. These allow Rover Runner to work its magic. Once these are set, I can expand the supergraph on the left to show its subgraphs. You'll notice that these say Apollo and local next to them. If it says Apollo, that's because it's pointing to the URL that Rover Runner fetched using the Apollo Studio API. If I click on the pencil icon, I can easily change my subgraph to point at the local URL instead. If I want to override the Apollo Studio URL, I can just click that pencil there, and then that'll let me type in any URL I want to point to instead, and that'll upgrade in the Supergraph JSON. Now that we've set which subgraphs we want to run locally, I can go to the Supergraph name and click the play icon. Here, you'll get a choice to either run your local subgraphs normally or in debug mode. Let's run it in debug mode for now. Once I click that, it'll open up 3 terminals in our case. A Redis terminal, a terminal to start the local subgraph. You'll see it has a little bug icon, just to show it's the debugger, and the Rover terminal. The Rover terminal waits for the local subgraphs to start and then calls Rover dev with a dynamically generated Supergraph YAML. Down here, you'll see it successfully pulled the schema from subgraph 1 and composed a Supergraph schema with our local subgraph. Now that our Supergraph is running, we can debug it. In this example, I just added a new field in subgraph 2 called name length that requires the name field from subgraph 1. I want to make sure that my resolver is getting the name properly, so I'm going to place a breakpoint right here on the returns. Now that the breakpoint, sorry, it's not playing. All right, now that the breakpoint has been set, let's go over to Apollo Studio, where you'll see that it's pulling the schema from the router to allow for autocomplete. Let's head over to Documents and set up our query. In this case, the query accepts a thing, generates a name for said thing, and calculates the name's length. In this case, let's make the thing my favorite dessert, chocolate babka. I'm going to type it out. And when I run the query, VS Code will automatically open paused on my breakpoint in the VS Code debugger. This will let us view any variables and scope on the left. Here, we can see that I correctly set up my requires directive because our resolver got the name Chocoholic Babka. I guess it's not terrible. If we go back to Apollo Studio, we'll see that it returned the ID as Chocolate Babka, the name is Chocoholic Babka, and the name length as 16. So if we counted the name, you would actually see that it's only 15. Unfortunately for me, the length property in JavaScript includes white space. So let's fix our resolver. I'm going to go back to Apollo Studio, or sorry, rather back to Visual Studio Code, and I'm going to add a dot replace here to rename the space character and remove that space. Nothing too fancy. I'm currently working on getting this next part automated, but for now, after I save my file, I can go back to the subgraph terminal, press Ctrl-C to stop my subgraph, and then just use the up arrow to reuse the command and restart it. Once it's running, the Rover CLI will recompose the supergraph, adding my subgraph back again, along with any new schema changes I might have made. I'm going to be optimistic here and just remove my breakpoint for this case. Now, let's go back to Apollo Studio and try running our query again. So, since we cache our name, it should be the same, and you'll see over there that our name length is now 15. So it works. Please hold your applause for the end. Now, since our resolver is perfect without any bugs, it's time to shut down our router and local subgraphs. So let's go back to VS Code and open up Rover Runner on the left. Here, you can either click stop on the supergraph or hit the stop icon at the top to close everything, including the Redis. Once we click that, the Rover CLI will be stopped and closed, followed by all the locally running subgraphs, and lastly, the Redis terminal. So we'll see that it closes, and then it'll pop away. All right, so while this might have been a very small example, using Rover Runner has had a real-world impact for us, enabling us to support and debug for numerous initiatives, such as we had an entire iOS mobile rollout to 2 million monthly users, and now we have over 6 million requests per day for this app. So here, you can see a little video I took. This shows off articles, watch lists, market data, recommendations, and a lot more stuff. But speaking of recommendations, we recently rolled out another initiative called My News 2.0 Dashboard. So for a little context, this dashboard is a brand new personalized page for tons of subscribers, currently only bundle subscribers, but soon all of them. And these articles are recommended based on a user's specific interactions. And these include articles they might have just clicked on. This poses an interesting issue for us, because that means we can't just cache a query with a private scope. If we did that and the user were to click an article, read it, and then press the back key, they would be recommended the same article they just read. Instead, we need to get a perfect blend between caching at the CDN, caching at our subgraphs, and caching the articles themselves at the data source level. So Rover Runner was essential for this, because it allowed us to use the VS Code debugger with the two subgraphs that needed changing. So here's a little example with my demo subgraph that I showed off. So if you look over here, I'm able to easily debug and examine the mysterious info argument that you get in all your resolvers. This lets me modify the cache control for our use case to test. So we were able to quickly iterate on different cache times in order to find the perfect blend between data source caching and query caching. So after this talk, if you're interested in trying Rover Runner for yourself, I'm excited to say that as of this presentation, Rover Runner is now available to download on the Visual Studio Marketplace, and it's 100% open source. One thing to keep in mind, though, is that since we only just made it public, it is a bit hyper-focused for the Dow Jones use case. So if you need any features, please reach out to me after this or at my topic table and let me know. I can add them. Or since it's open source, you can just make a PR yourself. So lastly, giving credit where credit's due, this Visual Studio Code extension, even though it streamlined our work, it wouldn't have been possible without the Rover CLI and all the hard work Apollo put into it. So let's now shine a light on their amazing CLI and see just what exactly happens when you type Rover dev into the terminal with a Supergraph YAML file. First, it'll attain the subgraph schema from your YAML by either introspection or a file path. You can provide either. Next, it'll compose a supergraph schema with that subgraph schema, and it should look something like this. From there, it spins up its own local router session for you using that supergraph schema, similar to how you would run the router like this. The big difference, though, is that it then repeats this process, fetching each subgraph from the supergraph YAML one by one, and it recomposes the supergraph schema each time for new additions. Once all the subgraphs have been added, you can query it in the Apollo sandbox like I just did. Additionally, Rover Dev will continue checking the subgraphs necessary for any new schema changes, and it'll update the supergraph schema if it's necessary. With that, I'll give you guys a bit of time back. If you have any feedback, feel free to leave it here, or you can find me in the puppy pen tomorrow. Or if you have any questions, feel free to stop by my topic table or contact me on LinkedIn using this QR code. Thank you guys and have a great day.